Now we're going to try and sketch graphs in polar coordinates. So let's try and sketch this graph here. So when you're working polar coordinates, try to gear your mind into thinking like this. So when theta is 0, it starts in this direction. So you're trying to read this here. As theta varies, you're trying to keep track of the radius. So theta starts here. So it's like this. So theta is moving around like this. It's increasing all the time. And each step of the way, you're going to need to know the radius. So theta is going to move around like this. Theta here is increasing each step of the way. As it increases each step of the way, you're going to need to know the radius. So when you're thinking polar coordinates, think like this. Theta is increasing each step of the way. Each step of the way, you're going to need to keep track of the radius. Let's say the radius is here, 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 and then theta is increasing, so you're keeping track of the radius as theta is increasing. So theta is increasing each step of the way, and you're trying to keep track of the radius. Let's just make this up. So as it turns out, when it's so as it turns out, you might do something like this. Because you're trying to keep track of the radius as you increase theta. So when you're working in polar coordinates, try to gear your mind into thinking like this. Theta is increasing each step of the way. Theta is increasing each step of the way, and you're trying to keep track of the radius as theta is moving about. So later on it will trace out, I don't know, maybe it will trace out a path. Okay, and something else you should bear in mind is that yes, we could go all the way around like this from 0 to 2 pi, or we can do it like this. So theta is increasing each step of the way. So take it all the way to pi, and then so this is your positive direction. You are entitled to go in the negative direction. So once you've done this one sweep, you could go all the way around again. But just know that you are entitled to go in the opposite direction. So now it's negative. So this is 10. So this here is pi over 4, and then so this here is positive pi over 4. Well, going in this direction would be negative pi over 4. The point that I'm trying to make here is that you could do this. Make one sweep all the way to pi, and then start again, but then go in the opposite direction. So now you're in the minus theta realm here. So theta here is going in the other direction. Just bear that in mind. Well, let's try and sketch this now. So we are trying to sketch this graph here. But then if you look at this, theta is increasing each step of the way, and you need to keep track of the radius. So we need to know the radius each step of the way. So let's try and work out the radius. So we are trying to sketch this graph. Because we're working with cosine, try to select values that are easy to work with. So remember, we need to work out the radius each step of the way. So hang on. So each step of the way, so select easy values to work with. Well, because we're working in cosine, these values are easy to work with. So when theta is 0, when theta here, remember we are just trying to keep track of the radius. Our ultimate polar graph will look something like this. This is just us. So in order for us to sketch this graph, we need to work with this first, and then from here we can jump to here, because we need to keep track of the radius. We're going to use this thing here to keep track of the radius. Okay, so to sketch this, select easy numbers to work with. So these are easy numbers to work with. When theta is 0, what is the radius when theta is 0? So put 0 into here. Cosine of 0 is 1. So this thing here will be 1. This thing here, 1 plus 1 will be 2. So it will be here. The radius. So what that means is, remember we're doing this when the angle is 0. When the angle is 0, the radius will be 2. So it'll be right here on our graph. And then when theta is pi over 2, so when theta is pi over 2, so that when theta is pi over 2, it is cosine here would be would be 0, and then you plus 1, so that would be here. So what that means is so theta is increasing like this. By the time it gets to pi over 2, the radius will be 1. The radius, so by the time it gets to pi over 2, the radius will be somewhere here. Okay, when theta is pi over 4, when theta is pi over 4, what is cos pi over 4? So this thing here, you should be able to remember. It is create your triangle like this, 1 1. If you create your triangle 1 1, then this has to be root 2. Well, cos would be this thing here. So it's actually this thing here will be 1 over root 2. So it would be, so when theta is pi over 4, the radius will be 1 plus this thing here. So let's just guess it to be somewhere around here, because this thing here is roughly 0.7. So you got 1 plus 0.7. So this thing is 1 plus 1 point. Well, it would be somewhere around here, and then use the same technique, and the radius would be somewhere around here. So it's a smooth transaction here. Okay, so once you've got, we are trying to sketch this graph, but then we need to keep track of the radius. So we would use this bit here in order to keep track of the radius. Once we've got this bit here, we can then sketch this graph here. So hang on. So we are trying to sketch this. Select values that are easy to work with, and it will overall it will give you this thing here. So this is a way of us keeping track of the radius as we increase theta. So what's happening is this: you start here. So we are increasing theta all the way to pi. So each step of the way. So when theta is 0, the radius will be 2. So this here is 1, 2. So it would be right here. So when it's at pi over 4, so by the time it gets to pi over 4, which will be here, the radius will be 1 plus 1.7 something. So remember, so radius that is 1.7 something. So it would be somewhere around. Hang on, let me think. 2. So it's probably somewhere around here. Okay, around here. And then by the time it gets to pi over 2, which is here, pi over 2, the radius will be 1. So 1, hang on, 1 is this is 1, so it'd be right here. So you can see that it's doing something like this. And then by the time it gets to 3 pi over 4, so theta is increasing like this. By the time it gets to this bit here, then the radius here is quite small. So by the time it gets to 3 pi over 4, the radius is quite small. So let me tidy this up. So hang on, let's start again. So when it's 0, when theta is 0, it will be 2. When it's at pi over 4, the radius will be 1.7 something. Will be somewhere around here. And then when by the time it gets to pi over 2, which will be along here, the radius will be 1. So it'd be something like this. And then let me think. And then by the time it gets to 3 pi over 4, which is somewhere along here, the radius is very small. So it's going to be very small like this. And then dead on pi. So that's all. So the radius is increasing all the way around here. By the time it gets to pi, the radius will be 0. So the radius being 0 will be right at the pole or the origin. So as it turns out, it will look like this, something like this. The radius is decreasing. The radius is decreasing as you make. Hang on. As you make the sweep like this, the radius is decreasing each step of the way. So as it turns out, it will give you this spiral. It will give you this spiral here. And then if you look at this, hang on, if you look at this, this is very similar to me saying it's an even function, because if you have the negative version, remember cos looks like this. Cos is an even function. So if you put a negative version in here, everything will be the same. So if you look at this here, hang on. If you look at if you put pi over 2, the radius will be here. So if you put pi over 2, now if you put negative pi over 2, then it's you going in the other direction. Negative pi over 2 will give you the same answers. It's like an even function. So the radius will be the same as over here. So as it turns out, because it's in a way a symmetrical, it's very similar to being symmetrical. It will be like a reflection along this axis here. So as it turns out, your graph will look something like this. It's symmetrical along this line here. Well, get yourself a graph plotter and plot it, and it will give you this. Okay. I will give you some more examples in the next video.